Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we will evaluate some definite integrals using fundamental theorem of calculus, which says that if a function is continuous on interval ab and small fx is derivative of capital Fx, then integral a to b fx dx is equal to f of b minus f of a. To find definite integral a to b fx dx, we first find f, then we will calculate f of b minus f of a. To find f, we will use the same technique that we have used in indefinite integrals. Now let us do some questions. Here is the first question. Here we have to evaluate this definite integral, that's integral from 0 to 1 by 1 plus x square. Okay? From indefinite integrals, we know that integration of 1 by 1 plus x square is equal to tan inverse x. But here we have to apply limits, that is limit from 0 to 1, that is equal to tan inverse 1 minus tan inverse 1, that's upper limit, minus tan inverse 0, that's lower limit. And we know that tan inverse 1 is equal to pi by 4, because tan of 45 or tan of pi by 4 is equal to 1, minus tan inverse 0. Tan 0 is 0, so this is equal to 0. Thus, we get pi by 4 as the result. So therefore, integration of 1 by 1 plus x square with limits from 0 to 1 is equal to pi by 4. This completes the question. Now, our next question is, here we have to evaluate this definite integral, that's integral from 0 to 1 x by x square plus 1, and we will evaluate this by using substitution method. So for that we put x square plus 1 equal to t, because if we differentiate x square plus 1 we get 2x, and here in numerator we have x. Now differentiating t with respect to x, we get dt by dx equal to, it is differentiation of x square is 2x and differentiation of 1 is 0, so we get 1 by 2 dt equal to x dx. Also, when x is 0, we get 0 square plus 1, that is 1. So when x is 0, t is equal to 1. And when x is 1, we get 1 square plus 1, that's 2. When x is 1, at that time t is equal to 2. Now we can write integral, and we have to replace the limits of x, that is 0 to 1, with the limits of t, that is 1 to 2. So we can write integral from 1 to 2. Now instead of x dx, we can write 1 by 2 dt. So it is 1 by 2 dt. And instead of x square plus 1, we can write t. That is equal to 1 by 2 is constant, so take it out. Then we have 1 to 2, 1 by t dt. We know that integration of 1 by t is equal to log of t, so we can write this is equal to 1 by 2 is constant, it is equal to log of t with limits from 1 to 2. That is further equal to, it is 1 by 2, it is log of upper limit, that's log of 2 minus log of lower limit, that is log of 1, but log of 1 is equal to 0, so we get 1 by 2 log of 2. Okay, so that is the answer. Thus, value of integral 0 to 1 x by x square plus 1 is equal to 1 by 2 log of 2. That completes the question. Now let's take one more question. Here we have to evaluate this definite integral, that's integral from 0 to 1 sine inverse 2x by 1 plus x square. We will evaluate this integral by using substitution method. We know that twice tan theta divided by 1 plus tan square theta is equal to sine of 2 theta. So we put x equal to tan theta. Now put x equal to tan theta. Differentiating x with respect to theta, we get dx by d theta equal to secant square theta, or we can write dx is equal to secant square theta d theta. Also, when x is equal to 0, at that time we get tan theta equal to 0 and theta is equal to 0, because tan 0 is equal to 0. Also, when x is equal to 1, we get tan theta is equal to 1. So at that time theta is equal to pi by 4, because we know that tan of pi by 4 is equal to 1. Now we can write integral. Now instead of 0, we have to write this 0 to 0, and instead of this upper limit we have to write pi by 4. Then we have sine inverse, it is 2x by 1 plus x square. Instead of x we have tan theta, so we write 2 tan theta divided by 1 plus tan square theta. Then instead of dx we can write secant square theta d theta. Okay, or that is equal to 0 to pi by 4 sine inverse, this is equal to sine of 2 theta, it is sine of 2 theta, and then we have secant square theta d theta, or that is further equal to, it is 0 to pi by 4. Now this is sine inverse sine of 2 theta, that is equal to 2 theta. Then we have secant square theta d theta. Okay? Now this is further equal to, 2 is constant, we can write 2 here. Then 0 to pi by 4 theta into secant square theta d theta. Now from here we will use integration by parts. For that, 2 is constant, so we write 2 here. Now we have to integrate this, keep theta as it is, then integration of secant square theta is tan of theta minus integration of, now differentiation of theta is 1 And integration of secant square theta is tan of theta. So we can write 1 into tan of theta is tan of theta. Okay, d theta. And limits is from 0 to pi by 4. This is further equal to, it's twice theta tan theta, then minus integration of tangent of theta is equal to minus times log of cosine of theta or log of cos of theta. So it's already minus here, so we get plus log of mod of cosine of theta, the limits from 0 to pi by 4. Now we apply limits. This is further equal to twice. The upper limit is pi by 4. So we get, instead of theta we have pi by 4. It's pi by 4 tan of pi by 4 minus, plus log of cos of pi by 4. Then minus times lower limit, that is 0. When you put theta equal to 0, this becomes 0. Okay, then we have it is 0, then we have plus minus is minus, it is log of cos of 0 is 1, so it is log of 1. Okay, this is further equal to, it's 2 times pi by 4, then tan of pi by 4 is equal to 1 plus log of cos of pi by 4 is equal to 1 by root 2. It is 0 minus log of 1 is also 0. So we get this much. That is equal to, multiplying with 2, so we get pi by 2 plus 2 times log of 1 by square root of 2. Or we can write it like this, it's pi by 2 plus twice log of 1 by 2 raised power 1 by 2. That is further equal, it is pi by 2 plus 2 into 1 by 2, it's log of m raised power n, that is log of, that is n log m, is 1 by 2. And that is equal to pi by 2 plus 2 by 2 is 1, so we get log of 1 by 2. That completes the question. Now, in my next lecture, we will learn about properties of definite integrals. Till then, take care of yourself. Thank you.